In one of our last lessons, we were looking at acceleration, and I showed you this equation, v equals u plus at. And in this equation, v is the final velocity, so something's running down a runway, and v is the final velocity that you measure. And u is, we call the initial velocity. A is our acceleration, and t is our time. And we looked at that equation, and that's a relatively easy equation to use. There are a couple of others that are harder, and I did start talking to you about them, but let's now look at a couple in detail. One of them is this: S equals ut plus a half at squared. It's one of the biggest equations you will come across. You're aiming for level 7, 8 and 9. You have to be able to use this equation. You won't have to learn it off by heart. It'll be on the equation sheet given to you. And again, going through this, S is distance. That's how far something's gone. U is the initial velocity again. T is time. The half, we can see, A is the acceleration, and remember please, acceleration is measured in meters per second, meter per second squared. And the t here, look at this again, the same as this t here, but this one is squared. And that means that's the same as t times t. So how does this get used when we have questions? Well, a couple of things to bear in mind. Very often in a question, they might not tell you this, but look to see if the object is at rest before it starts. So if I send something moving, its initial velocity must be 0. Let's assume that's the situation here. So S would be 0 times t plus a half at squared. And obviously 0 times t is nothing. So it goes. So in those sorts of questions where the initial velocity is 0, S is a half at squared. Now the question often asks you to do things like, what is the acceleration? Let's get this on its own. And this is where students struggle. And I'm going to go back to something I've used with several of you. Let me write the equation using this notation. The S is here, because it's on the top, equals, still there, the half, there's the half, 1 up and 2 down. A, t, squared. They're all at the top because they are at the top. I want A on its own. Everything simply has to follow the movement of the arrows, and you can't go wrong. So let's move the 2. It goes up here to there. Let's do that. The 2 comes across here and goes there, 2 times S. The 1, let's move it anyway, comes down and goes to here. The t squared is t times t. You can do one at a time if you want, but they might as well go together. It's at the top, so it goes down and it ends up here. So we now rewrite this. We have 2s divided by t squared equals a. And it's the same thing as saying a equals 2 times s over t squared. And that's how you work out equations involving an object that starts at rest, say you're dropping something, and you don't know its final velocity, but you do know how far it went and how long it took to get there. Now this is something you can try yourselves at home, because you can take any object, your phones have clocks on them, stop clocks, and you could time dropping it yourself, maybe out of an upstairs window if you're careful, and time how long it takes to hit the ground. And then that would work out for you using this equation, the acceleration of the object. It would be 2 times the height it fell, divided by the time squared. Now that's an interesting one to try, and to give you a little bit more than just bookwork. Thank you.